Hello everyone, this video is going to show how to rearrange alperts temperature correlations for solving for the heat release rate, the Q dot term. So if we have close right above the flame where R over H is less than or equal to 0.18, we have a temperature of some detector at a point is equal to our ambient temperature plus 16.9, the heat release rate to the 2/3 power divided by the height above the flame to the 5/3 power. So we want to follow standard algebraic procedures to solve this for Q dot. So first we're going to subtract T infinity over to the other side. And this is equal to what's left, 16.9 Q dot to the 3/2 divided by H to the 5/3. And we're going to multiply whatever's in the denominator. Once we have only a fraction left, we're going to multiply whatever's in the denominator across. So we'll have what we have over here, temperature of the detector minus T infinity multiplied by H to the 5/3 is equal to 16.9 Q dot to the 3/2 power. And we're going to divide by 16.9. Multiplication, then powers. So we'll do multiplication first. So temperature of the detector minus T infinity times H to the 5/3 divided by 16.9. So now it's going to equal Q dot to the 3/2 power. And when we have powers and we want to get whatever variable they're affecting by itself, we're going to flip the power and raise the other side to the inverse of whatever power we're working with. So we have T detector minus T infinity times H to the 5/3 over 16.9. This quantity raised to the 2/3 power, and that's equal to Q dot. So this is what we're looking for. Now we can solve for the heat release rate that will give this detector temperature. Now, if our R over H value is greater than 0.18, we would use this equation where the temperature of the detector is equal to T infinity plus 5.38 to multiplied by the heat release rate divided by the radius from the center line of the fire times 2 raised to the 2/3 power divided by H. So we can tell this one has an R in it, so it's not close to the center line of the fire. So once again, first we subtract the T infinity to the other side, and we would have 5.38 times Q dot over R to the 2/3 power divided by H. So next we'd multiply whatever's in the denominator across, so we'd have temperature of the detector minus T infinity multiplied by H, and that would equal 5.38 times Q dot over R to the 2/3 power. And then we would divide by whatever the multiplying factor is. So we have temperature of the detector minus T infinity multiplied by H divided by 5.38 is equal to Q dot over R to the 2/3 power. So now we need to take this power to the other side, so we would inverse it when we go to the other side. So temperature of the detector minus T infinity multiplied this quantity multiplied by H, and then that divided by 5.38. And we take that quantity and raise it to the 3/2 power, and we do is flip this, take the denominator, put it in the numerator, and vice versa. So that's equal to Q dot over R. And then we're just going to multiply R across. So we'll have what we have on this other side, temperature of the detector minus T infinity, that quantity multiplied by H divided by 5.38. That whole quantity raised to 3/2 power multiplied by R, and that's equal to Q dot. So this is what we're interested in if we're farther away from the center line, if our R over H value is greater than 0.18. So I hope you found this useful, and have a good day.